This video is about adding powers of 2. So let's start with 1 plus 2, and then 1 plus 2 plus 4, then 4 terms. It will be 1 plus 2 plus 4 plus 8. We are always adding the next power of 2. Here 1 plus 2 plus 4 plus 8 plus 16. So to get the next power of 2, the only thing we need to do is to multiply the previous one times 2. So here 1 times 2 is 2, and then 2 times 2 is 4, and 4 times 2 is 8, and so on. And the first number with 1 is 2 to the 0. Now let's record the results. If we only have the number 1, then that's it, 1. When we add 1 plus 2, we get 3. When we add 1 plus 2 plus 4, we get 7. Then here we have that same sum plus 8, so 7 plus 8 equals 15. And then in this sum, we have 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, and 15 plus 16 equals 31. Now, notice this relationship here between the result of the sum in a given row with the last power of 2 that we are adding in the next row. See, 1 and 2, 3 and 4, 7 and 8, 15 and 16. There is a difference of 1. The result of the sum is always 1 unit less than the next power of 2. So let me write that down here. 1 is 2 minus 1, and then 3 is 4 minus 1, 7 is 8 minus 1, 15 is 16 minus 1, 31 equals 32 minus 1, and so on. This just keeps going. Like when we start adding powers of 2 like that, from 2 to the 0, which is the number 1, and then increasing 2 to the 0 plus 2 to the 1, and so on, we are always going to get 1 unit less than the next power of 2, and that will be the next power of 2 relative to the last one we included in the sum. So 2 to the 0 plus 2 to the 1. Here we're just rewriting the same thing, but we are making it explicit with the exponents. 2 to the 2, and then the next one is 2 to the 3. So here we have just the number 1, which is 2 minus 1, but 2 is 2 to the 1, so we can rewrite this as 2 to the 1 minus 1. Here we have 1 plus 2, which is 3, but 3 is 4 minus 1, so this is 2 to the 2 minus 1. Here we have 1 plus 2 plus 4, so that one is 7, and 7 is 8 minus 1, but 8 is 2 to the 3. See, the next power of 1, the next power of 2 minus 1. Here the next power is 2 to the 4, which is 16, and then minus 1 is 15, which is the result of that sum. So let me write the notation in extended form. For any arbitrary number, we're going to use a letter to represent the exponent where we're going to finish. So 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus, and then we just write dots to indicate that the sum continues, and this sum is going to stop at some power of 2 that to the exponent n, where n is an arbitrary number. So that's the last power of 2 that we are adding. And then here we have the sum. The result of the sum is going to be 1 unit less than the next power of 2. So we increase the exponent by 1. So we make it 2 to the n plus 1. That's the next power of 2. And then we subtract 1 from that power. And now the sigma notation for that same equation or property of powers of 2. So we're adding, this is an abbreviated notation for the sum, we're adding powers of 2, so all our terms are of the form 2 to the k, so 2 to some exponent, and the values that that exponent takes are given here. The smallest one we start when k equals 0, and we're going to stop when k equals n, just as above. This is a more compact notation for the same thing, and the result of that sum is this expression 2 to the n plus 1 minus 1, which is just expressing in a more concise form all the possibilities that the examples that we have here above. And this needs to be proven by mathematical induction, but that will be for another video. So that's it for now. Thank you very much for watching, and have a good day.